Hey there, and welcome to The Explainer. Today we are diving into how scientists describe, classify, and, at the end of the day, understand every single thing in the physical world around us. So how does a chemist see the world a little differently than the rest of us? Well, let's crack open that toolkit and see what's inside.
So let's kick things off with a question that, it seems almost too simple. Why are windows made of glass and not, copper or wood? It sounds obvious, but by the end of this explainer, you'll be able to answer this question just like a chemist would.
And here's the roadmap for how we're going to get there. First up, we're going to learn the difference between the amount of something and its type. Then, we'll see how every single substance has its own unique fingerprint. After that, we'll do a quick tour of the 3 states of matter, and we'll wrap it all up by looking at how matter can change its form. Okay, so first things first, amount versus type. Now, this is maybe the most fundamental way chemists start to sort, everything. It's really all about separating what a thing is from simply how much of it you have. Okay, so on one hand, we have what are called extensive properties. These are the characteristics that totally depend on the amount of stuff you're looking at. Just think about mass or volume, for example. A giant boulder obviously has way more mass and takes up way more space than a tiny little pebble. It's the same kind of rock, but the amount changes the property. Makes sense, right? And on the other side of the coin, you've got intensive properties. These are the things that are just, built into the very nature of the stuff itself. They have absolutely nothing to do with the size or the amount. Think about color. A tiny little fleck of gold has the exact same brilliant color as a whole brick of it. That's an intensive property. It helps define what the substance actually is. Okay, so let's put them side by side for a second. Extensive properties, mass, volume, that's all about how much. Intensive properties, color, hardness, that's all about what is it. And let me tell you, this distinction is absolutely crucial for any chemist who's trying to figure out what exactly they're looking at. So if the intensive properties are what define a substance, how do we actually use them? Well, that's where this idea of a substance's fingerprint comes in. It's this unique set of properties that lets a chemist identify pretty much any material you can think of. But first, we gotta be super clear about what we mean here. When a chemist talks about a substance, they're talking about something pure, matter that has a totally uniform and definite composition. Think of a pure copper wire or a perfectly cut diamond. Every single tiny piece of it is the exact same stuff. And this is the absolute core idea right here. Every single sample of a substance has the exact same intensive properties. And why is that? It's because every sample has the same composition. It's the reason why a teeny tiny speck of gold has the exact same color and hardness as a giant gold bar. So what are these identifying traits? We call them physical properties. These are qualities that you can observe or measure without actually changing what the substance is made of. We're talking about things like its hardness, its color, whether or not it conducts electricity, or even its malleability, which is just a fancy way of saying you can hammer it into super thin sheets without it breaking. And check this out, because this table illustrates the point perfectly. Look at water. It always melts at 0 degrees Celsius and boils at 100, every single time. So if you find some clear liquid that boils at 78 degrees, well, you know for sure it's not water. It's probably ethanol. See? These numbers, they're like a unique chemical fingerprint. No two are exactly alike. All right, so beyond those unique fingerprints, one of the most obvious physical properties is something you already know really well. It's the state of matter, the big 3, solid, liquid, and gas. Let's just do a quick breakdown of what defines each one on a slightly deeper level. Let's start with solids. A solid has a definite shape and a definite volume. Think about it, the particles are just packed in there, super tight, in a really orderly way. Imagine an ice cube in a glass. It doesn't just spread out and fill the bottom, right? It holds its shape. And because of that tight packing, it's also almost impossible to compress. Then you've got liquids. Well, a liquid has a fixed volume, but it's a bit of a rule breaker when it comes to shape. It just takes the shape of whatever container you put it in. The particles are still pretty close, but they've got a bit of freedom to, slide and flow past each other. That's what lets you pour a glass of water. And that brings us to gas, the true free spirit of the bunch. A gas takes on both the shape and the volume of its container. The particles are so far apart and moving so fast that they'll just expand to fill whatever space you give them. And all that empty space is also why gases are super easy to compress. Oh, and here's a quick little detail that's actually pretty important. We tend to use gas and vapor like they're the same thing, but in chemistry, there's a slight difference.
Gas is for stuff like oxygen or helium that's already a gas at room temperature, whereas vapor is what we call the gassy version of something that's normally a liquid or solid, like water vapor rising from a pot of boiling water.
Okay, so we've talked about what matter is, but what happens when it changes? This brings us to our last section, changes in form. Well, that's what we call a physical change. It's when some of a material's properties change, like going from a solid to a liquid, but the actual composition, the stuff it's made of, stays exactly the same. Check out this gallium metal. It literally melts from the heat of a person's hand. Its shape totally changes, but it is still 100% gallium. And believe me, these kinds of changes are happening all around you, constantly. The obvious ones are those changes of state, right? Boiling water, freezing it into ice, melting it back into water. But physical changes can be way simpler too, like breaking a pencil, grinding coffee beans, or crushing a can. In every single case, you've changed the form, but you haven't changed what it's made of. Now, even within a physical changes, we can break it down a little more. Some are reversible. Think about freezing and melting water. You can go back and forth all day. But other physical changes, like cutting your hair or cracking an egg, well, those are irreversible. Yeah, there's no hitting the undo button on cracking an egg. And all of this, every single concept we've talked about, brings us right back to where we started. Now that we have the chemist's toolkit, let's answer it. So, why are windows made of glass?
The answer, of course, is all about its unique set of intensive physical properties. First, glass is transparent, which, is kind of the whole point of a window, right? It's also hard, so can be held in place inside a frame without sagging, and it's a pretty bad conductor of heat, which helps keep your house warm in the winter and cool in the summer.
And that is the big takeaway here. We choose materials for very specific jobs based entirely on their unique bundle of intensive properties. We use copper for electrical wires because it's a fantastic conductor. We use glass for windows because it's transparent and hard. The properties of a material literally dictate its purpose. So I'll leave you with this final thought. Just look at whatever device you're watching this on right now. Think about it. What intensive properties define its screen, its casing, its guts? What makes each part perfect for the job it has to do? It's amazing. The world starts to look a little different when you're thinking like a chemist. Thanks for joining us on The Explainer.